Here we have another video, sheet lightning video, to show you how to do plane cutting. So cutting the end of a part at an angle using a plane. So first let's create a part. Let's put this in aligned to an axis, let's say the x-axis, and let's give it a length, let's say of 800 millimeters, and just drop it in place there. Let's give it also a diameter here of 500 millimeters, and remembering the size of that because the plane needs to be larger than this diameter to do an effective cut. So if we now create another part, and I'm going to align that to the y-axis, and I'm going to make it 800 millimeters long, just to make sure it's bigger than 500 and big enough for the purpose of cutting this. This obviously is a cylinder at the moment, but when I press OK on the second part, it comes up with the part editor, and here I have the chance to change the section, so I can change it from circular to rectangular. I can set the width to 0. I can set the height to 800. Remember, it was 800 millimeters long. It's now also 800 millimeters high, so I have a square plate effectively there, and I say OK to that. So that's dropped in that new part, that plate that I'm going to use to cut this. So the first thing I need to do, as we did on a previous video with junctions, I'm going to have to first link this to that to get any kind of cut. So let's click on this part, click on the drag tool, click on the centerline snap, and then snap to this center line, and then we need to type in a position 400 millimeters. This is 800 long, so we want to get the center, so let's type in 400 here, and that's the point from which it's going to drag it, and in fact link it to this. When I choose snap node, this node is highlighted, and I'm going to snap onto there. So I'm going to use this to cut that. Obviously now if I weld now, there's going to be no change because there's no angle between these two. So let's have a look at that in 2D. There's the plane, and it's doing nothing basically. It is forming a cut, but it's not anything that's visible because it's equal to the normal just outline piece. So let's give this an angle by using the normal activate. There we get several nodes highlighting, allowing me to activate the part. That means bring it back into active movement as it was when I was originally creating. But because the center node is pinned to this part, it pivots around that. So what I need to do now is find an angle. So I'm going to use here the angle snap, and I'm going to say, okay, I want an angle of 60 degrees. And this is highlighted in green to say, okay, choose the object you want to form this angle to. So it's the angle between the center line of this and the center line of that. So there we find that this plane is now snapping to 60 degrees. So this has been covered in other videos. So I'm going to drop this at 60 degrees there. I'm going to cancel the matching because it doesn't make sense in this case to match. And if I weld this now, we can see that we get a plane cut. So plane cutting is as simple as that. It's about using a part that is, this has a height, a width of 0, a height that is sufficient to cause that cut. That's by changing the orientation of the center line and using these snap tools, center line and T-snapping, that kind of thing, or perpendicular snapping and angle snapping, we can get the angle that we want. There's also another way to get this. If we double click on there is this general tab, and there's a Z angle here. Now if we did the same thing with the circular part and looked at the general tab, it would appear as a seam, and we can actually move the seam using this. And set that to 90 degrees, say. Oops, that's 0.9, so that's 90 degrees, and it moves here, look, to a 90 degree angle. So it's going to unfold it from there. If we again, so we cancel the matching. Again, if we double click on this and we go to the general tab, we can type Z angle, which is like seam, but what it does is roll the part over. So if you type 45 degrees, there it's rolled the part by 45 degrees. If we type minus 45, it's going to go the other way. So let's accept it at minus 45 degrees and say OK, and then cancel the matching and then say weld it up, and there we see we've got a plane cut piece, which if you look at it from 2D, it's cut in two angles there, one that I've turned the center line of the part, the other that I've rotated that plate over and used it as a cutting plane. If this wasn't big enough, it wouldn't produce a valid intersection, so you do need to make this plate big enough. If it's not long enough, you obviously have to go back to make a longer piece, but if you just want it to be higher, you can alter this to say 1000 and it will instantly alter that. Cancel the matching again and say weld it up, and there you have an example of how to use plane cutting